Alright, this video is over surface area of cylinders, and it's mainly for if you missed class, weren't here today, you need to look over the notes, or if you're studying, preparing for a test, you could use this to kind of go over things. But surface area of a cylinder, first of all, let's just kind of review what a cylinder is. The cylinder has two parallel bases, and the cylinders, both of those bases are circular, they're circles. Okay, so one thing, they're either going to give us, we need to know the radius or the diameter or both. And then the height is the measurement from in between the two bases or in between the two circles, the distance in between the two circles. So let's kind of get an idea of what this cylinder would look like if we kind of opened it up. Okay, of course we've already talked about the two bases, the top and the bottom are both circles. And then the lateral surface, the side surface, if we flatten it, opened it up and flatten it out, that's going to form a rectangle. We already know the formula for the area of both of those shapes. If you remember, the formula for area of a circle was area equals pi r squared. And since we have a circle there, we also have a circle here, so it'd be the same formula. And for a rectangle, if you remember, we used area is equal to length times width. Well, if I'm looking at this rectangle compared to this cylinder, I notice that this distance here is the same distance as the height of the cylinder. So for one of these measurements, I can plug in the height of the cylinder. For the other distance, I need to know how far it is from here down to here. And if we stop and think about a circle and the distance around the outside of a circle, which is the circumference, the distance from this edge to this edge would be equal to the circumference of that circle. And we know that circumference, the formula is circumference equals pi times diameter. If you need a minute or two to get that down in your notes, just go ahead and pause and start back up when you're ready. But let's look at a couple of examples. First of all, from what we just talked about, here's our surface area formula. Okay? Remember, we had two circles, the top and the bottom, and the area of a circle was pi r squared. So we need to double that, so we're multiplying it by 2. And we decided that if we added the area of the lateral surface, and we came up with this formula, which would be h, the height times pi times the diameter. In this case, we have a cylinder that has a height of 10 and a radius of 5. So let's just kind of notate what we know. Like we said, we have a radius of 5. We have a height given of 10. And what we know about the relationship between a radius and a diameter is that it takes two radiuses to equal one diameter. So the diameter would also be 10 as well as the height. So once we discover that, let's go ahead and look at our formula. Our surface area formula was 2 pi r squared plus h pi d. From this point, it's just a matter of plugging in the measurements for the corresponding variables. So when we look at this, we've got 2 times pi times the radius. Well, the radius was 5, so let's go ahead and plug it in. Plus the height, well, the height was 10, times pi times the diameter. The diameter was also 10. So all we've done is taken the information we've already had, plugged it in, substituted it into our formula. Now we're going to take our trusty calculator, and it's going to do the majority of the work for us as long as we plug it in correctly. When we enter this and we hit if we enter this correctly and hit enter, it's going to give us, it's going to give us 150 pi, but the steps are, we get 5 squared is 25 times 2 is 50, that's where the 50 pi came from. 10 times 10 is 100, there's where the 100 pi came from. We put that together, and that's 150 pi. Now, we know that we can convert that into an actual, well, it'll be an estimate because pi is not an exact number. This number is actually more exact than the number we're going to come up with. that if we hit that conversion key and we round it to the nearest tenth, we're gonna come up with a surface area of 471.2 square centimeters. All we did was plug the information in and let the calculator do the rest of the work. And remember, surface area is, think of it this way, how much would it take to cover the top, the bottom, and the lateral surfaces without any overlapping? That's what we're talking about when we're talking about surface area. Let's look at one more example, and this time we're just going to look at an example of lateral surface area. Sometimes if we're dealing with, say we're dealing with piping, piping is a cylinder, but it's hollow. It doesn't have the two bases. It doesn't have the top and the bottom. They're open, so liquid or gas can flow through. So on that we use a different formula. We're going to use the lateral surface area formula, which is just height times pi times diameter. Now you notice we cut out that first half. We cut out 2 pi r squared because we don't need the area of the bases. So let's take a look at what this looks like. On this one, let's go ahead and get our measurements that we're given. We were given the radius, which was 7. We're given the height, which is 9. We know that if we double the radius, we'll have the diameter, so 7 times 2 is 14. Our lateral surface area formula is height times pi times diameter. So it's just a matter of replacing the variables with the corresponding measurements. We have a height of 9, so we're going to plug 9 in. We have a diameter of 14, so we'll plug 14 in there. We'll go ahead and enter it into the calculator. Calculator is going to give us this answer of 126 pi, which we know is an accurate answer. And then, but if we want it in terms of easier to read, we're going to go ahead and hit that conversion button, and it's going to tell us that it is 395.8 inches squared. Now again, this is an estimate because pi is an irrational number. So if there's any questions, I hope you guys will come to me with those, and I sure hope this helps you.